Hello everyone. And welcome to the Mathmatecher channel. Let's suppose that a and u0 are two different from zero natural numbers. And let's suppose that un is a geometric sequence that has u0 as a first term, and the number a as a reason, such that u1 square plus u2 plus 35 times a square equals 2009. So, at first, we're asked to find all the natural numbers that the square of which divide 2009. And then, to calculate the value of each of the reason a, and the first term u0. After that, we have to write the general term un, as a function of the natural number n. Then, to write the sum Sn, that equals u0, plus u1, plus so on, until un, in terms of n. And finally, to find the value of the natural number n, for which the sum Sn, would be equal to 800. So, let's start by finding the natural numbers that the square of which divide 2009. For this, we will factorize the number 2009 and write it as product of prime numbers. So the first prime number by which the number 2009 is divisible is 7. When dividing the number 2009 by 7, we find the number 287, which is also divisible by 7. And the division of 287 by 7 gives the number 41, which is a prime number, and when we divide it by itself we finally find the number 1. Therefore 2009 equals 7 squared times 41 times 1. And from this scripture, we deduce that the natural numbers of which the square divides 2009 are 1 and 7. Now let's calculate the value of each of the reason a, and the first term u0. So, as we have the relation, u1 square plus u2 plus 35 times a square equals 2009, and as our sequence un is a geometric sequence, we can deduce that u0 times a all square plus u0 times a square plus 35 times a square equals 2009. And by extracting a square as a common factor from these terms and moving it to the right side of the equation, we find that u0 square plus u0 plus 35 equal 2009 over a square. We will note this as equation number 1. Now as we're looking in this equation for u0 and a as natural numbers, and as we found in the first question that the only numbers that the square of which divide 2009 are 1 and 7, then the only possible value that the number a can take are 1 or 7. Now, for a equal 1, the equation number 1 implies that u0 square plus u0 minus 1974 equals 0. And if we calculate the discriminant delta of this second degree equation, we find that it is equal to 1 minus 4 times 1 times minus 1974, which equals 7896. But as the number 7896 is not a perfect square, the equation u0 square plus u0 minus 1974 equals 0, do not have natural solutions in this case. Therefore this value of the number a, which is 1, is refused. Now for a equals 7, the equation 1 would imply that u0 square plus u0 minus 6 equals 0. And if we calculate the discriminant delta of this equation, we find that it equals 1 minus 4 times 1 times minus 6, which equals 25. Which mean that for this value of a, which is 7, we find as a solution for the equation 1, the number minus 3 that we refuse because we're looking for natural values for our first term u0, and the second solution, which a valid value for u0 is the number 2. So the values of the reason a, and the first term u0, of our geometric sequence are respectively 7 and 2. Now, let's write the general term un, in terms of n. So, as un is a geometric sequence, then the term un equals u0 times a to the power of n, which equals 2 times 7 to the power of n. Now let's express the sum Sn of the n plus 1 first terms of our sequence in terms of n. So, as Sn is the sum of n plus 1 terms of a geometric sequence of reason 7 and a first term u0 which equals 2, we find according to the formula of the sum that Sn equals u0 times 1 minus a to the power of n plus 1, all over 1 minus a, which equals 2 times 1 minus 7 to the power of n plus 1, all over 1 minus 7, that equals 1 over 3, times 7 to the power of n plus 1, minus 1. Let's now finish by finding the value of n for which our sum Sn would equal 800. So, as we've already expressed the sum Sn in terms of n, we deduce that for the sum Sn to be equal to 800, 1 over 3 times 7 to the power of n plus 1 minus 1 must be equal to 800. Which mean that 7 to the power of n plus 1 equals 2401. Which implies that n plus 1, all times the natural logarithm of 7, equals the natural logarithm of 2401. Therefore, n would be equal to the natural logarithm of 2401, over the natural logarithm of 7, minus 1, which equals 3. Now that we have answered all the question, we hope this video was instructive and that you learned from it, and if it is the case, we invite you to give it a like and to subscribe to the channel and click the notification bell for more videos like this, and until the next one. Have a great time.